Alrighty, so here we are on lesson 7, calculating probabilities of compound events. So in class the other day we talked about tree diagrams and how to use them and how it was an effective method of displaying the possible outcomes of certain multi-stage chance experiments. Additionally, in these situations, tree diagrams were shown to be helpful for computing probabilities. So we're going to use what we did the other day, and we're actually going to compute probabilities using tree diagrams. So I want you to flip to page 24 of your notes, where it talks about how we're going to use this tree diagram here with the B's and the C's. So from the first page, it talks about how B stands for board game. So write that down. And C stands for card game. That was the scenario from the other page. Okay. So the first question says here, if BBB represents 3 straight nights of board games, what does CBB represent? So we know that the C stands for, it'd be card game on the first night, then board game on the second night, and board game on the third night. Okay. The next question says, list all outcomes where exactly 2 board games were played over 3 days. So we want 2 board games. So that means if we're looking down the list, we're going to start with B, B, C, B, C, B, and skip the next one, and then C, B, B. It's actually our last one if you look down the list. So there are 3 total outcomes. Alright, so that was just kind of a bit of a warm-up. If you flip to the next page, this is where we really get into what the point of the video is. So they gave us this tree diagram with probabilities. So it says, in the example above, each night's outcome is the result of a chance experiment rolling the 4-sided die. Thus, there is a probability associated with each night's outcome. By multiplying the probabilities of the outcomes from each stage, you can obtain the probability for each branch of the tree. For this family, a card game will be played if a die lands showing a value of 1 on the board game, and a board game will be played if a die lands showing a value of 2, 3, or 4. So this makes the probability of a board game on a given night 0.75, which means that a card game, if we subtract that from 1, would have to be 0.25. Okay, so first they want to use a tree to find the probabilities for the 3 days. You can see they did the first one for you. And so all you're doing is you're multiplying the 3 probabilities. So for the next row here, BCC, we'd have 0.75 times 0.75 times 0.25. For the next one, we'd have 0.75 times 0.25 times 0.75. Now we have BCC, so 0.75 times 0.25 times 0.25. For CBB, we have 0.25 times 0.75 times 0.75. For CCB, we have 0.25 times 0.25 times 0.75. And then for all C's here, we have 0.25 times 0.25 times 0.25. Okay, so what I want you to do right now is to pause, calculate these yourself, and you can go ahead and round them to the nearest hundredth, and then unpause and check your answers on the screen. Alrighty, welcome back. So you should have these probabilities listed, and now we're going to use them to answer the questions. So probabilities for 2 of the 8 outcomes are shown. We calculated those. That was the first question. Next question, what is the probability that there will be exactly 2 nights of board games? So first we should list them out with the letters. So exactly 2 nights of board games would be B, B, C, B, C, B, and C, B, B. So now we know that each one of those, if we look at our picture, was 0.14, so we're going to add that up 3 times to represent those probabilities, and our grand total would be 0.42, which would be 42%. Right, the next question says, what's the probability that the family will play at least one night of card games? So we need at least one C. So we have B, B, C, B, C, B, B, C, 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 B, B, C, B, C, 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 B, and then the last one is the all C's. So now we need to add in these probabilities here. So we would have 0.14, we'd have 0.14, 0.05, let's see, C, B, B, I lost my place, this is 0.14, C, B, C, this is 0.05, C, C, B is 0.05, and then all C's is the 0.02. So if you add all of those up, you would get a grand total of 0.58. So I know some of you are probably like, Ms. Bold, there's got to be a better way to do this that's a little shorter, and there is. So at least one night of card games. So we could take our grand total 1 minus any probabilities that they don't play one night of card games, which would just be the B, B, B option. So if you do that, you would have 1 minus 0.42 from, and then when you subtract that, you'd get the 0.58, which still gives us our 58%. Okay, so if you flip onto the next page, we're actually going to stop here, and we're going to do the rest of this in class for our day 2. So we're going to stop here for this video.